Thanks so much for checking out this video. If you haven't done so, please hit subscribe and hit that bell icon so you don't miss any new content I release. And as always, check out my Instagram page at The Anatomy Gal. Let's do a really quick review of some basic numbers before we get to an example. So remember that you need to know these levels right here. And if you don't have these memorized, you won't be able to solve the problem. So make sure you memorize these value ranges right here. And recall that physiological pH or the blood pH is 7.35 to 7.45. If we have a number that is less than 7.35, that's an acidemia. And the thing that I want you to kind of think of right now is that an acidemia is either caused by too much acid in the body, or we don't have as much base to combat that acid. Likewise, if we have a number that is greater than 7.45, that's an alkalemia. And we could say the same thing over here. An alkalemia is either caused by too much base or too little acid. Then we have the PCO2, that just stands for the pressure, and that's measured in millimeters of mercury, so that makes sense for this unit over here. And that value is 35 to 45 millimeters of mercury. The way I like to tell students to memorize that is that the 35 to 45 is very similar to the numbers we see up here for the pH value range. So the PCO2 will have similar numbers to our pH, our physiological pH numbers. Whenever we think of the PCO2, there are two things I want you to think of. CO2, that is a respiratory waste product. So think of the respiratory system. And this is going to be really important when we're talking about whether a pH value is being compensated or not. So just associate this PCO2 with the respiratory system. The other thing I want you to associate this value with is the acid levels in the body. Now, this is a very kind of overgeneralized way of teaching this, but I think that if we start with the basics, we can always add in details later. And the reason why I like to describe the PCO2 as associated with being the acid levels is because this is related to that volatile acid, carbonic acid, which is represented by this formula right here. And the lungs will be involved with controlling very quickly acid levels in the body. And then finally down here we have the bicarbonate, and that is measured 22 to 28 milliequivalents per liter. Now I've seen a couple of different ranges. For my students, our lab manual says 24 to 28. I've seen 22 to 26. But for the sake of kind of including the different numbers that you might see, I just like to teach 22 to 28. And bicarbonate is a base, so that's why we will associate this with the base levels in the body. And we also want to associate the bicarbonate with the metabolic or renal system. Again, there's quite a bit more to it, but the reason why I like to do that is because we can relate these levels to the synthesis of bicarbonate, and one of the major places that takes place in the body is the renal system within the distal convoluted tubules and the collecting tubules of the kidneys. Okay, let's just take a look at this first example here. These numbers are just made up to kind of emphasize the points that I want to get across today. And the first thing we need to do is we need to evaluate our pH level. So with a pH of 7.31, we need to ask ourselves, is this high or low? We compare that to the values I told you to memorize, and we would see that 7.31 is lower than the low end of the physiological pH scale. So we would draw a down arrow. When the acid level is low like this, we know that that is some type of acidosis. So I always recommend that you at least get this information down. It gives you an idea of what kind of situation you're dealing with. Now let's go to the PCO2. The PCO2 levels were 35 to 45 millimeters of mercury. 55 is higher than the high end or the upper end of that. So we would say that the PCO2 levels are high. So we simply draw an up arrow like that. Then for the bicarbonate levels, remember our range was 22 to 28, and we would see that this number of 35 milliequivalents per liter is higher than the upper end of that value range. So we would say that the bicarbonate levels are also high. Recall that the question I wanted you to ask yourself is, okay, what are the two things that can cause an acidosis? Well, we either have too much acid or too little base. Those questions relate to what I told you to associate these two variables with. For the PCO2, remember we were thinking of what? Acid and respiratory. I'm just going to abbreviate. And for the bicarb, we wanted to associate this with the base and the metabolic system. So let's think. The PCO2 is elevated. What are the two things that can cause an acidosis? Either too much acid or too little base. So, okay, this level is elevated, so I'm going to go ahead and say that the PCO2 is causing this acidosis because we associate this with the acid. This is elevated. An elevated amount of acid causes an acidosis. Remember that these are inversely related because the pH scale represents the amount of hydrogen ion concentration. So the lower the pH, the more acidic the solution is. In this case, it would be the blood. So let's just go ahead and say that this is a respiratory acidosis, but let's just make sure before we start writing things down. You want to be able to tell a story about these problems. Okay, we have an elevated amount of base. Does an elevated amount of base cause an acidosis? It does not. Only an elevated amount of acid. So now we have for sure confirmed that this is a respiratory acidosis. So that's the first part to your answer. And I'm just going to abbreviate here, but make sure that you guys know how to write everything out. The second part of this, and again, this is a very basic kind of level 1 acid-base problem solving. We want to see if there's compensation. Compensation means, is the other system helping us out? So obviously we've got an issue with the lungs here that's causing this pH problem. So we need to see, okay, are the kidneys doing anything about it? So to determine that, go to the other system, which is right here, and see if things are normal or out of range. We can see here that we drew an up arrow because the bicarb levels are out of range. They are elevated. So let's think, why would the kidneys be producing more bicarbonate? Meaning, why are they going to synthesize new bicarbonate that gets absorbed into the blood? It's because this base is meant to combat the acid. So this base, being a higher pH, will help bring this number back up towards that regular value we looked at. So when we see that the other system is elevated, it makes sense then that it is trying to help the problem out here. So we would say that we have a respiratory acidosis with metabolic compensation. Again, I'm just abbreviating here. I like to make sure that we remind ourselves that it is the other system doing the compensation. A lot of times I'll just see students write respiratory acidosis with compensation. And that's fine. That's the correct answer. But do we understand that we have a team here, a team of these two body systems helping to solve this problem right here? So let's take a look at another example. Okay, looking at this example here, again, we always start with the pH. So a pH of 7.31, that is low. That means we have an acidosis. And what are the two things that cause an acidosis? It's either we have too much acid or too little base? I recommend that in the beginning, you go ahead and write all this stuff out. I know that's more work, but you'll very quickly get to the point when you won't have to write these things out because the story just makes sense to you. Okay, so now let's look at our levels, and I went ahead and I pre-wrote this information out just to make this go a little bit faster. So the PCO2, we're given 25. Remember, our range is 35 to 45. This is lower. So we would see that we have a low amount or lower than normal amount of PCO2. Okay, let's look at the bicarb levels. It's 20 milliequivalents per liter. Again, that is also lower than our low end of 22. So we would also put a down arrow there. I'll go ahead and put this here. So looking at this acidosis, it's caused by two things, either an increased amount of acid or not enough base in the body. So what part tells that story? Well, when we look at our acid, we have a lower than amount of acid. Does a low amount of acid cause an acidosis? It does not. So hopefully we're going to see that this base is the problem. When we go here, we see we have a lower amount of base. Does a low amount of base cause an acidosis? Yes, it sure does. So that means this acidosis is due to a metabolic reason, which is why we would call this a metabolic acidosis. Now let's see if there is any compensation. Remember, we have to look at the other system. So because this was a metabolic problem, we need to look at the respiratory system. For the respiratory system, we see that we have a lower than amount of acid being produced or contributed to the blood. Does that help this problem? It sure does. So really what the respiratory system is saying is that, hey, we realize that there's too much acid in the body. So what we're going to do is we are going to decrease the amount of acid to the blood to try to help that problem. Because at the end of the day, the lungs still need to function, right? But what they can do is we can control respiratory rate to try to help out this problem. So that's why we would say we have a metabolic acidosis with respiratory compensation. Okay, let's take a look at this example here. So we have a pH of 7.48. We know that that is higher than our normal range. So we'd say that that is an alkalemia or an alkalosis is another way you can say that. And what is an alkalosis caused by? That is either caused by too much base or too little acid or not enough acid, right? That makes sense for that story. So let's now look at our next values here. So we have the PCO2. Remember, what's the range for that? 35 to 45. That is lower, so we would put a down arrow there. And then for the bicarb, we have a value of 20 milliequivalents per liter. That is also lower. Why is it lower? Because that range is 22 to 28, so we put a down arrow there. So let's look here. What is an alkalosis caused by? Too much base. Okay, so let's go to our base levels. Do we have too much? No, we don't have enough. So let's just check out the other criterion. Do we have too little acid? Oh yes, we sure do. So the reason why we have an alkalosis in this problem is due to the respiratory system. So we would say that this is a respiratory alkalosis. Okay. So now we have to say, is there compensation? We go to the other body system and we would say, okay, let's look at that level. We have a decreased amount of base being produced by the kidneys in this instance, the metabolic system. Does that make sense with what's going on here? Yes, we have an alkalemia, meaning we have too much base in the body. The kidneys still have to function, right? So how can the kidneys kind of help out this situation? They can just decrease the amount of base that is retained inside the body. So we would say that yes, there is compensation. So this would be a respiratory alkalosis with metabolic compensation. Let's take a look at this example. Here, 7.48, we know that that is an increase in the blood pH, so that is an alkalosis. What are the things that cause an alkalosis? We have too much base or not enough acid. Okay, now let's look at our levels here. PCO2, 55. That is quite a bit higher than our 35 to 45 range, so we would say that this is an increase. Our bicarb levels are normally 22 to 28, so we can see that this 33 is also elevated. So what is causing this alkalosis? Do we have too much base? Okay, it sure does look like that, but I always like to make sure that we look at everything before we just jump to a conclusion. So that it does seem like we have a metabolic alkalosis, but let's look at the acid levels. Do we have not enough acid? No, we don't. This is the opposite. So for sure, we can say from these levels here, we have a metabolic alkalosis. Now, when we look at compensation, are the lungs doing anything to help this problem out? We see we have an increased amount of acid being produced by the respiratory system, and really what that means is retained within the body. And so that makes sense, right? Because this pH is high, we have too much base in the body. So what the lungs are going to do is they will retain more CO2, which ends up creating more acid in the body. And what that acid will do is it will bring this number back down towards a normal value. So we would say, yes, according to what we see here, we have a metabolic alkalosis with respiratory compensation. All right, let's take a look at our last example. I've been showing you examples where there was compensation, but what if there is no compensation? Well, the very good news for you is that these are the easiest problems to solve. Yay! So let's take a look at this. Our pH of 7.31 is low. That means we have an acidemia or an acidosis. Again, what are the things that cause an acidosis? Too much acid or too little base. Hopefully by now, you're not really having to write this down, or even if you are writing this down, you are anticipating this as I go through it in the video, and that's exactly where I want you to be. This bookkeeping is really meant to help you understand this long term, and then if you guys are going into branches of medicine where you'll be looking at ABGs and VBGs, you'll have a really solid foundation. So that's why I like to write things out over and over again, especially in the beginning. Okay, so now let's look at these levels. PCO2, a level of 38 millimeters of mercury. That is within normal limits. Okay, sometimes you'll see WNL. Remember, our range was 35 to 45. So this is within normal limits or within normal range. The symbol that I personally like to use when I'm teaching this is just a straight line like this. It means it's neutral. We aren't alarmed by that number there because it's normal. So let's look at the bicarb. At this point, you should be saying to yourself, okay, well, something is causing that because we do have an acidosis, but it's not really making sense just yet. So let's look at the bicarb levels. This level is lower than our normal range of 22 to 28. So we would say, okay, there's a down arrow there. Does this story match what we know about what causes an acidosis? Did we have too much acid? No, our acid levels are actually normal. Did we have not enough base or too little base? We sure did. So essentially what is happening in the body is we don't have enough base molecules or basic molecules, however you want to think of it, to equalize or keep that teeter-totter of acid-base balance level. So the acid molecules, those hydrogen protons, are really overpowering the blood. So we would say that due to these numbers here, we have a metabolic acidosis. Now for compensation, again, it's metabolic, so we have to go to the respiratory system. Is the respiratory system doing anything about this at this present time? No, the lungs are not, because this is in normal range. So you can kind of think of normal range as business as usual. The lungs are just kind of doing what they're doing as they normally would, and they're not retaining or expiring more CO2 to combat this. So we would say that this is an example. Whenever you see a value that is normal, you know immediately that there is no compensation. So we would say that this is a metabolic acidosis without respiratory compensation. Okay, so my big tips for acid-base problems is number one, remember that this is a very generalized, basic foundation for acid-base problems. When you guys are looking at ABGs, VBGs, so arterial blood gases or venous blood gases, there's actually quite a bit more to it, but this is an excellent starting point, in my personal opinion. You want to know these values. Always pay attention to, current literature that defines these values. I've seen this number change a couple of times just in the course of the years I've been teaching. So just make sure that when you guys are going into, those areas where you're having to pay attention to these numbers, that you just be mindful of that. But start there, ask the basic questions. Know the basic concepts that an acidemia is either caused by too much acid, too little base. Alkalemias are too much base or too little acid. And then tell a story. And that is going to take you much farther than just memorizing, my opinion, direction of arrows. And there's nothing wrong with that. But I always feel that if you guys can tell a story about this information, you really know it. So let me know in the comments what you think. I really hope this helps. I've had good feedback from my prior students who ended up going to nursing school, and they said this helped them a lot. So I really hope it helps you, and I'll see you guys in the next video.